Cambridge International, AS Physics, February-March 2021, Paper 22. Question 1 Part A. Complete Table 1.1 by stating whether each of the quantities is a vector or a scalar quantity. So, vector quantity is a physical quantity which has both magnitude and direction, whereas scalar quantities have only magnitude. So, in the given quantities, first one is acceleration. Acceleration is a physical quantity which depends on its direction. When the direction changes, the value of acceleration will also change. So, acceleration is a vector quantity, whereas power and work done are scalar quantities. Part B. The variation with time t of the velocity v of an object is shown in figure 1.1. So, we are provided with a velocity time graph of a object. Part 1. Determine the acceleration of the object from time t is equal to 0 to time t is equal to 4 seconds. So, we need to calculate acceleration from a velocity time graph. So, we can get acceleration from a velocity time graph by calculating the gradient of the graph. So, we have the time period that is from 0 to 4 seconds. In order to calculate acceleration, we just need to calculate the gradient of the graph during this section. So, we can calculate the gradient or the slope of the graph. In order to calculate gradient, we can draw a triangle. And with the help of the triangles, we can find the values of y1. Here y1 is 0.70 and y2 that is 1.40 and x1, x2. x1 is 0 and x2 is 4. So, first we need to write down acceleration is equal to the gradient of the graph, where we can calculate gradient using the equation y2 minus y1 over x2 minus x1. We have the values we can substitute, that is y2 is 1.4 minus 0.70, that is y1 value, over x2 4 minus x1 0. And the answer is 0.175. When we write into SF, we can write 0.18. The unit is already given in the question. This is a 2-mark question. So, in order to score 2 marks, we should write acceleration is equal to gradient. And the last mark belongs to the final answer. Going to part 2, determine the distance moved by the object from the time t is equal to 0 to t is equal to 4 seconds. So, again for this same time duration, we need to calculate the distance covered. So, we can calculate the distance covered by the object from a velocity time graph by calculating the area under the graph. So, here in order to calculate the distance covered during the time period from 0 to 4, we can calculate just the area under the graph during this time period. So, we need to calculate the area of this shaded portion. In order to calculate easily, we can divide it into 2 parts. One is a triangle and another one is a rectangle. And we can see for the triangle, the base is 4 and the height of the triangle is 0.75 minus 1.4, 0.70 minus 1.4. So, we will get 0.70. So, that is the height of the triangle. And for the next or remaining part, that is a rectangle, here we can find what is length and breadth, where breadth is 0.70 and length is 4. So, now we can find the area of this shaded portion. First, we need to write distance will be the area under the graph. This is a very important step you should write in order to score 1 mark. So here the area under the graph is the area of the triangle plus area of the rectangle, where the equation to calculate area of triangle is half BH and the area of the rectangle is length into breadth. So we can substitute the values. First, area of triangle half times base is 4 times height is 0.70. This is the area of triangle plus area of rectangle, that is length into breadth, where length is 4 times breadth is 0.70, which we have already measured from the given graph. And the answer is 4.2 meter. Part C, define force. So we can define force using Newton's second law of motion. According to the second law of motion, force is rate of change of momentum. So we can write that statement. We will get 1 mark for this statement or definition, that is force is rate of change of momentum. Part 2, the motion represented in figure 1.1 is caused by a resultant force acting on the object. So we have seen the velocity of the object is keep changing from the velocity time graph of the object given in figure 1.1, and it is due to the resultant force acting on an object. On figure 1.2, sketch the variation of force with the time from 0 to 12 seconds. Numerical values of F are not required. So by looking at the velocity time graph given, we should be able to detect or describe how is the force applied on the object in order to have these velocities or velocity changes. So here we should understand, or we should draw a force time graph with the help of the velocity, or by looking at the velocity values we should be able to understand about the value of force. So here initially we need to check what is the relation between force and velocity. So here we can use the equation force is mass into acceleration. So force is equal to mass times acceleration is rate of change of velocity, and mass is constant here. So from this we can write force is directly proportional to rate of change of velocity. Now what is this delta V over delta T? That is rate of change of velocity. But from this graph, delta V over delta T is the gradient of the graph, because we know that gradient is y-axis, change in y-axis over change in x-axis value. Here on y-axis it is velocity, so we will get delta V over, on x-axis it's time, so delta T. So from the first graph, the gradient of the graph is delta V over delta T. The same delta V over delta T we are having in this relation, and delta V over delta T is the gradient of the graph. So we can write down force is directly proportional to the gradient of the first graph. Now we can check the gradient, what is happening to the gradient. So this velocity time graph is having 3 types of gradient. Initially, gradient or slope is a constant value, but it is keep increasing. So during the time interval from 0 to 0.4, that is during this section, we have seen a gradient is a constant value and the gradient is positive. So a positive constant value, and we have already calculated this gradient in the first section to calculate acceleration, and we got the gradient is 0.18. So we can draw somewhere here as 0.18. Simply you can consider as the numerical exact value does not require, it's mentioned. So somewhere here I am considering as 0.18, that is acceleration. Then it's a constant value. So we will get a straight line. Now from the time interval between 4 seconds to 8 seconds, the gradient is different. From 4 seconds to 8 seconds, we can see the gradient is 0 or there is no slope. So during this section, between the time interval 4 to 8, gradient or slope is 0. So the graph of force or the value of force is 0. So we have to draw a line in 0 value on x-axis. Now we can check what is the gradient of the graph between the time interval from 8 seconds to 12 seconds. So again we can go back to the graph. And during the section from 8 to 12, this is the gradient, this is the slope. And we can understand this gradient or this slope is almost double than the initial gradient, because during the 4 seconds of time, it changes its velocity from 1.4 to 0. But slope or gradient is negative as it's going downwards. So we can conclude here the gradient during this section is again a constant, or it's more steeper. So we will get but negative constant because it's a straight line, but it is more steeper force value or initial gradient. The gradient during the last section is greater, but it's negative. So we can draw, actually it is double. So the double of the initial value, negative axis it should be drawn, so that we can draw below the x-axis. But still it is constant. So we will get a straight line. Now we can complete it. So this is the force graph, which completely depends upon the gradient of a velocity time graph. Part A, state what is meant by work done. So in order to write what is meant by work done, we can look at the equation of work done. Work done is force times distance or displacement in the direction of the force. That means if we have a box and if we are applying a force in this particular direction, how much the box has displaced or moved, this distance or displacement, that is the distance moved by the object in the same direction of force applied. As you can see, the force applied towards right and the object has displaced also towards right. So the product of force and the displacement of the object in the same direction of the force will give you the value of work done. So we can write work done is force times, or it's a product of force and displacement of the object, but we can count only the displacement in the direction of the force applied. That is very important. So we can write displacement in the direction of force. Part B, a beach ball is released from a balcony at the top of a tall building. The ball falls vertically from rest and reaches a constant terminal velocity. The gravitational potential energy of the ball decreases by 60 joule as it falls from the balcony to the ground. The ball hits the ground with speed 16 meters per second and kinetic energy is 23. Show that the mass of the ball is 0.18 kilogram. So here we have a beach ball which is released from a balcony at the top of a tall building. So a ball, initially it is releasing from a height and it's falling downwards. As the ball was moving or falling from rest, its initial velocity is 0. But while falling towards ground, when it reaches some distance, it has reached a constant terminal velocity. So let's think at this point, the ball has reached a constant velocity, that is its terminal velocity. Let it be v. So once the ball reached its terminal velocity, from there throughout the motion till it reaches the ground, it will maintain its terminal velocity. So once the ball reached terminal velocity, then throughout the motion it will have the constant velocity. Let it be v here till it reaches or touches the ground. About gravitational potential energy, it's mentioned that gravitational potential energy of the ball decreases by 60 joule as it falls from the balcony to the ground. So when the ball falls down, we know that height reduces to 0. So there will be a decrement in gravitational potential energy, and which is given, that is 60 joule. When the ball hits the ground, it is having a speed of 16 meter per second and kinetic energy is 23 joule. So we have the final velocity, that is the same as terminal velocity, which is given 16 meter per second, and which will be same even at the end. While it touches the ground, it will have the velocity 16 meter per second. And during this time, when it touches the ground, its kinetic energy is also given. Kinetic energy is 23 joule, and we know that at the top, as the ball was at rest, its kinetic energy is 0. So the change in kinetic energy of the ball from the initial point to final point, that is delta kinetic energy or change in kinetic energy, is the final kinetic energy, that is 23 joule minus initial kinetic energy 0 joule. So we will get 23 joule. And in first section we need to calculate mass. So we have the change in kinetic energy value. So we can write this equation of this, that is change in kinetic energy is half times mass times change in velocity. So here change in kinetic energy value we have, that is 23 joule is equal to half time mass times change in velocity. That is the difference between final velocity and initial velocity, that is 16 minus 0. So we will get 23 is half times m times 16. We can make mass as the subject, so we will get mass is equal to 23 times 2 over 6. So in this equation, kinetic energy is half mv square is there, so we need to square this 16, it should be 16 square. So kinetic energy equation half mv square, please note it down. So you have to square 16. So we will get 0.18, and the unit of mass is kilogram. So that is the correct answer. This is a 2-mark question. So first mark is for writing the equation of kinetic energy, and the second mark is for the substitution and showing the answer. Next question, calculate the height of the balcony above the ground. So here we need to calculate the total height of the ball travel. So here we have the potential energy at the initial position, which is given 60 joule. So we can write down gravitational potential energy, that is mgh at the height h is 60 joule. So in order to calculate height here, we can make height as the subject. So we will get 60 over m times g, that is 60 over mass of the ball, which we have calculated in previous section, times g is gravitational constant 9.81, and the answer is 34 meter. So this is also 2 mark question, where 1 mark you will get for writing the equation of gravitational potential energy and for the substitution, and the final mark is for writing the answer into SF. Part 3. Determine the average resistive force acting on the ball as it falls from balcony to the ground. So here we need to calculate the average resistive force. So we have a ball which is falling towards ground from a height of 34 meter, which we have calculated in the previous section. Initially the ball was at rest, so all its energy was in the form of gravitational potential energy, and the gravitational potential energy at initial position was 60 joule. And when the ball reaches at the ground, as we know that its height will be 0, so all its gravitational potential energy when the ball touches the ground will be 0. Some of its energy converted to kinetic energy, and the kinetic energy of the ball when it is touching the ground is also given in the previous section, that is 23 joule. So totally or initially the ball had a 60 joule of energy in the form of gravitational potential energy. While it is touching the ground, gravitational potential energy is 0, kinetic energy is 23 joule, and the remaining energy will be lost in order to work done against the resistive force. So we can write down the total lost happened to the gravitational potential energy, or lost in gravitational potential energy will be equal to the gain in kinetic energy of the ball when it reaches the ground plus the remaining energy consumed by the ball in order to work done against the friction, or energy consumed against the friction. So the same equation we can write down, changing kinetic energy. Instead of work done, we can write the equation of work done, which we have discussed in the first section of this question. That is, work done is equal to force times the distance moved by the object. Here it is the height. So that is the change in gravitational potential energy. Here we have the change in gravitational potential energy, or the potential energy lost by the ball is 60 joule, as initially it had 60 joule of gravitational potential energy. While it touches the ground, its gravitational potential energy is 0. So the change is 60 joule. Kinetic energy is 23 plus force times height is 34. So here only the unknown is force, so we can calculate the value of force easily just by rearranging the equation. So we will get force is equal to 60 minus 23 over 34, and we will get 1.1 Newton. Part C. State and explain the variation, if any, in the magnitude of the acceleration of the ball in B during the time interval when the ball is moving downward before it reaches constant terminal velocity. So here we need to state and explain what happens to the acceleration of the ball during the time interval when the ball is moving downwards before, very important, before reaching the constant terminal velocity. So you just need to mention what happens to the acceleration of the ball from its initial position till it reaches the terminal velocity. So let's look at the figure. The ball initially at rest, but when it starts to fall down, its velocity increases. But at certain point, before the ball touches the ground itself, ball reaches a constant velocity that is known as terminal velocity. After reaching the terminal velocity, the ball maintains a constant speed and speed is not changing. But for the ball from initial position till the position where the ball gains terminal velocity, its velocity is increasing from initial velocity 0 to its final velocity, that is 20, not 20, terminal velocity 16. So we can find out that during this section, as the velocity increases, there must be an acceleration. But how is this acceleration? Is it increasing or decreasing? And we need to state it and explain it. So as we know that force is directly proportional to acceleration. In order to describe about acceleration, we can check about force, because they are directly proportional. So when force increases, acceleration will increase. When force decreases, acceleration will decrease. So here, when the ball is at its initial position, we can look at the forces acting on the ball. One is its weight, which is mg, which will be always constant. So weight is acting downwards and there is no resultant force. So upward force is 0. So that at the top, the only force acting on the ball is its weight, which is acting towards the ground. So the ball will accelerate in the same direction of the weight towards the ground. When the ball falls downwards, as its velocity increasing because of the acceleration, the air resistance or the resistive force on the ball will increase. It's because the speed or velocity is proportional to the resistive force or air resistance. So this is a very important point. As the speed increases, the resistive force will increase. So initially the speed was 0, so the resistive force was 0, but gradually the speed is increasing, so the resistive force will increase. So after reaching some point, when we are looking at the ball, the weight of the force will be still acting downwards with the same value as its initial, but there will be an upward force, that is the air resistive force, which will be gradually increasing, so that the net force acting on the ball will now reduced, because we need to subtract the air resistance which is acting upwards from the weight. So the resultant net force acting on the ball is less now, so that the acceleration will gradually decrease, or the downward acceleration will decrease comparing to the initial position of the ball. So first point we can write about the air resistance. So air resistance acting on the ball increases. So the resultant force acting on the ball also decreases. So when we are drawing the force diagram of ball at different position, so initially when the ball is at the top position, its weight will act downwards and upward air resistance is 0, so that the net force will be acting downwards. But when the ball falls downwards, its weight still acting downwards will have the same value, but as its speed gradually increases, there will be an upward resistive force, so that the net force will be the difference of these two forces. So the net force will be less. When the ball reaches the terminal velocity at this point, its weight will be acting downward, but equal amount of a resistive force will be acting upwards. So the net force at this point will be 0, because there is an equal upward and downward force which will cancel out. So the net force when the ball reaches the terminal velocity will be 0. That is why there is no acceleration. So the ball keep moving with a constant velocity. So as force acting on the ball decreases, acceleration will also decrease. So we can write down acceleration decreases. So we have written 3 points. We just need to mention about acceleration. before it reaches the constant terminal velocity. So these 3 points are enough. Question 3. A spring is extended by a force. The variation with extension x of the force F is given in figure 3.1. So in this question we are provided with a force extension graph of a spring. Part A. State the name of the law that relates the force and extension of the spring shown in figure 3.1. So it is Hooke's law which state the relation between force and extension of a spring, and that is directly proportional. So from the graph we can understand, as it is a straight line passing through the origin, the force and extensions are directly proportional, and it's Hooke's law. Part B. Determine the spring constant in Newton per meter of the spring. So here we can use Hooke's law, that is force is Kx. In order to find spring constant K, we can make K as the subject, so we will get force over x. From the graph we can check for particular value of force what is its extension value. So here I am taking 4 as the force. So when force is 4, what is its corresponding extensions we can check. So by extending we can understand it is 2.8. We can substitute. When force is 4, its extension is 2.8. It's in centimeter. We need to convert into meter because we should get the answer in meter. So in order to convert from centimeter to meter, we should multiply it with 10 to the power minus 2. So 2.8 times 10 to the power minus 2, and that is equal to 140 into SF. So the answer, spring constant, is 140 Newton per meter. Part 2. The strain energy or elastic potential energy in the spring when the extension is 4 centimeter. Here we can use the equation, that is energy is half times force times extension. So we can check for the extension x is 4 centimeter, what is its F value. From the graph we can find out this point is the point where extension is 4 centimeter, and we can check what is its corresponding force. And the force value at this point is 5.6. Now we can substitute these values, that is x is 4 and force is 5.6 in the equation. So we can substitute half times force is 5.6 times extension is 4. But since it is centimeter, we should convert it to meter by multiplying with 10 to the power minus 2. Answer is 0.11 joule of strain energy. Part C. One end of the spring is attached to a fixed point. A cylinder that is submerged in a liquid is now suspended from the other end of the spring, as shown in figure 3.2. The cylinder has length 5.8 centimeter and cross-sectional area 1.2 into 10 to the power minus 3 meter square, and weight is 6.20 Newton. The cylinder is in equilibrium when the extension of the spring is 4 centimeter. So the upthrust, that is an upward force acting on the cylinder, we need to show its value 0.60 Newton. So first of all, we can check what are the forces acting on the cylinder. There are 3 forces acting. One is the weight of the cylinder, that will be acting downwards. Weight of the cylinder is given 6.20 Newton already in the figure. And there will be a tension acting on the spring or the force on the spring, that is tension. And according to Hooke's law, we have the equation for this force acting on the spring, that is equal to spring constants time extension of the spring. Then the third force is the upthrust acting on the cylinder, and which will also direct upwards. And in this question, we need to show that this upthrust force is 0.60 Newton. There is another important information is given in the question, that the cylinder is in equilibrium when the extension of the spring is 4 cm. That means when the extension of the spring, that when x is 4 cm, the cylinder is in equilibrium. This is very important term. That is when equilibrium, we know that the total upward forces acting on the cylinder will be equal to total downward force. So here weight of the cylinder, which is the only force acting downwards, it must be equal with the upward forces, that is the force on the spring plus upthrust. So here weight of the cylinder is mg and force on the spring is kx. Using Hooke's law, we can write force on the spring is equal to spring constant times extension plus upthrust. In order to calculate upthrust, we can make upthrust as the subject. So we will get upthrust is equal to mg minus kx. We can substitute the values here. Mass of the, or here weight is directly given. So instead of mg, we can write as weight itself. So weight is 6.20 Newton minus spring constant of the spring. So this is the same spring which we have done in first part, and its spring constant k we have calculated, that is 140. So we can substitute this value in the place of spring constant, as we are using the same spring here. So 140 times extension. So for this spring, when the extension is 4 cm, what is the force? But we just need to find out the extension of the spring. Sorry, that is already given. That is extension is 4 cm. So we can directly substitute 4 cm. So 4 into 10 to the power minus 2. And the answer is 0.60 Newton. Part 2. Calculate the difference in pressure between the bottom face and the top face of the cylinder. So here we must know that the difference in pressure between the bottom face and top face of the cylinder is the reason for upthrust. So we can use the equation. Pressure is force over area. But in this case, the change in the pressure is equal to the force due to this change in pressure, that is upthrust over area of cross section. So the upthrust force we have already calculated in the previous section, that is 0.60 over area of the cylinder, 1.2 into 10 to the power minus 3, because it's already given in the question, that is area is 1.2 times 10 to the power minus 3. So we can substitute in the equation, and the answer is 500 Pascal. Here 1 mark you will get for writing this equation, and the final 1 mark is for getting the answer correctly. Part 3. Calculate the density of the liquid. So here we can use the equation. Change in pressure in a fluid is the product of density times d times g times change in height. So in order to calculate density, we can rearrange the equation and we can make density as the subject. So we will get change in pressure over g times delta H. So change in pressure we have already calculated in the previous section, that is 500 over g value is 9.81 times change in height, So that is the height of the cylinder, which is 5.8 centimeter. So we can substitute here. Delta H is 5.8 centimeter, that is 5.8 times 10 to the power minus 2. Answer is 880. So the density of this liquid is 880. The unit is already given in the question. Part D. The liquid in C is replaced by another liquid of greater density. State the effect, if any, of this change on. Part 1. The upthrust acting on the cylinder. So when the density of the liquid increases, what will happen to the upthrust acting on the cylinder? So here we know that upthrust in a liquid is due to the pressure difference in a liquid, and the pressure difference is equal to rho g and times change in height. So from this equation we can understand, when the density increases, change in pressure increases, so upthrust also will increase. So we can write increases. Part 2. The extension of the spring. To check about the extension of a spring, we can look at the equation when equilibrium, as total upward forces equal to downward force. Weight must be equal to the force on the spring plus upthrust. When density increases or decreases, or when it stays same, the weight will be always constant. Weight of the cylinder will be constant. But in the previous part, we have already understood that when the density increases, upthrust will increase. So now by looking at this equation, in order to maintain the LHS of the equation constant, as weight will be always constant, and when upthrust increases, the force on the spring must decrease. So we can understand that force on spring, that should decrease, and the equation of its force on spring is Kx, where K is a constant. That means its value is not going to increase or decrease depending upon the density. It will be always constant. So when the force decreases, so definitely the extension will decrease. So we can write the extension of the spring decreases. 5. A source of sound is attached to a rope and then swung at constant speed in a horizontal circle as illustrated in figure 5.1. The source moves with a speed of 12 meters per second and emits sound of frequency 951 Hz. The speed of the sound in air is 330 meters per second. An observer standing a very long distance away from the source hears the sound. Part A. Calculate the minimum frequency to 3 significant figures of the sound heard by the observer. So there is a sound source which will keep emitting sound waves and which is moving in a circular path with a uniform speed. So the sound source is keep rotating with uniform speed, which is 12 meters per second. Here the speed of the source is given, that is we can represent with Vs, and the speed of sound in air also given, we can represent with V, that is 330. Then the frequency of this sound wave, that emitted sound is having a frequency 951. So that is the original frequency of the sound. We can represent with the letter Fs, source frequency. And we need to calculate what will be the observed frequency by this person and observed minimum possible frequency. That is very important. So in order to answer this question, we should know about Doppler effect. So we can consider 2 positions and we need to check when the source is at which position the observer can hear a sound wave with a least frequency. So we can consider 2 positions. One is here and one is the other side. When the source is this side, as the direction indicates, the sound source is moving towards the observer as it's circulating in this direction. At this particular point, we can say the sound source is approaching to the observer. So here, when the source is approaching, the wavelength of the sound wave will be less comparing to when the source is moving away. When the source is here, suppose, so it will be moving away from the observer. In this case, the waves behind the source will be having a higher wavelength. So this is something very important. When the source is moving away, the sound wave will be having a higher wavelength behind the source. Whereas when the source is moving towards the observer, the sound wave will have a higher wavelength. Therefore, we can conclude that when the sound source is moving towards the observer, it is having a higher wavelength. When the wavelength is higher, here the frequency will be lower because they are inversely proportional. So, in this particular case, the observer can hear the lowest frequency or minimum frequency when the source is moving towards him, because he can hear the sound with greater wavelength and hence least frequency. So we can understand that this minimum frequency is possible when the source is approaching. So therefore we can use the equation of Doppler effect when the source is approaching, that is observed frequency is equal to source frequency time speed of the sound over speed of sound plus source speed. Here we have all these values. We can substitute, so we will get 951 times 330 over 330 plus 12, and our answer in 3SF is 918 Hertz. Part B. The circular path of the source has a radius of 2.4 meter. So the radius of the circular path is given. Determine the shortest time interval between the observer hearing sound of minimum frequency and the observer hearing sound of maximum frequency. So initially we can check which all points when the source is at, the observer can hear minimum frequency and maximum frequency, and we have already realized in the previous section that when this object is at the position as shown in the figure, it is approaching, the source is approaching towards the observer, so he can hear the sound wave with a minimum frequency. Likewise, when the object is at the point at the other side of the circle, when the source is moving away, the observer can hear a sound with a maximum frequency. So here the observer can hear a sound with minimum frequency, and after traveling the sound source and reaching the other part of the circle, the observer can hear a frequency with maximum frequency value. Hear a sound with maximum frequency value. And here we need to calculate the shortest time interval between these 2 points, or what is the time taken by the source to reach from these 2 points. So by looking at the figure, we can understand it is a semicircle distance, or from this we can write down the distance between these 2 points is equal to half of the circumference of the circle, where circumference equation is 2 pi r. So half of 2 pi r we will get pi r. And the speed of the source is also given, that the sound source moves with a speed 12. So we have the speed of the sound source, that is 12 meter per second. Now we have distance and velocity, so we can calculate the time using the equation speed is equal to distance over time. From these we can calculate time by rearranging the equation. Time is equal to distance over speed. So the distance is pi r over v. So the radius of this path is already given. We can substitute all the values, that is pi times r is 2.4 over the speed, which is 12. And the answer is 0.63. So 0.63 seconds. 6 part A, state Kirchhoff's first law. So Kirchhoff's first law states about the current at a junction in a circuit. Suppose this point is a junction in a circuit and there are currents which is flowing I1 and I2 into the junction and I3 and I4 away from the junction. Then the sum of the current into the junction, that is I1 plus I2, will be equal to the sum of the current flowing away from the junction, I3 plus I4. This is Kirchhoff's first law. We can write sum of current into junction is equal to sum of current out of the junction. Or in other words, you can write the algebraic sum of currents at a junction is 0. Part B. A battery of electromotive force 12 volt and internal resistance R is connected to a filament lamp and a resistor as shown in the figure. So this is a battery which is having 12 volt EMF and a internal resistor R, which is connected to a parallel combination of one lamp and a resistor. The current in the battery is 3.6 ampere and the current in the resistor is 2.1 ampere. The IV characteristics of the lamp is shown in the figure. So two important informations given in the last statement, that is the current in the cell, that is the total current flowing here is 3.6 ampere. Out of this 3.6 ampere, some of the current is flowing through the resistor. So that current flowing through the resistor is 2.1 ampere. So we can calculate what will be the current flowing through the lamp. The total current is 3.6 because that is the current flowing from the cell. Out of 3.6 ampere of current, 2.1 ampere is flowing through the resistor. So the remaining will be flowing through the lamp. So that the current in the lamp will be is equal to the total current in the circuit minus the current flowing through the resistor. So we will get 1.5 ampere. So we can write this first. That is the current through the resistor is the total current minus current flowing through the, current through the lamp will be is equal to the total current, that is 3.6 minus 2.1, which is the current flowing through the resistor, and the value we will get 1.5 ampere. Now we need to calculate the resistance of the lamp. So we have to calculate R. I we already have. So if we have V value, we can use the equation V is equal to IR. So we can find out what is the voltage of this lamp when the current value is 1.5 ampere. For that we need to look at the current voltage graph of the lamp, and we can check when the current is 1.5 ampere, what is the corresponding voltage across the lamp. So we can extend this to the graph, then to the x-axis. So from the graph we can get the voltage here is 4.4 volt. Now we have the voltage across the lamp also, that is 4.4 volt when the lamp current is 1.5 ampere. Now we can use the equation V is equal to IR. And in order to calculate resistance, we can make resistance as a subject. So we will get V over I. We can substitute the values, that is 4.4 over 1.5. Answer is 2.9 ohm. Always the answer should be written into SF. Part 2. Determine the internal resistance R of the battery. Here we can use the equation. EMF of the cell is equal to terminal voltage plus lost volt. So EMF is equal to, we can find out what is terminal voltage. Here in the question it's mentioned that the voltage across the lamp is 4.4 volt. Because we that calculated from the graph, that is the current flowing through the lamp was 1.5. So during that time we got from the graph its voltage across the lamp will be 4.4. Now we can look at the figure again. So we have the voltage across the lamp is 4.4 volt and the same value will be the voltage across the cell, and that is terminal velocity, because voltage across parallel combination will be always same. Therefore terminal velocity will be the terminal voltage. So we can write terminal voltage of the cell is 4.4 volt. We can substitute that value in this equation. Okay, so here we will get EMF is V terminal, which we have just find out from the figure, plus lost voltage. The equation of lost voltage is the current through the cell times internal resistance. So the EMF is 12, which is given in the question, and terminal voltage is 4.4 plus the current flowing through the cell is 3.6 times R. So we can calculate R by rearranging the equation, and R is 2.111. So into SF it is 2.1 ohm. Part 3. The initial energy stored in the battery is 470 kilojoule. Assume that the EMF and the current in the battery do not change with time. Calculate the time taken for the energy stored in the battery to become 240 kilojoule. So here initial and final energies are given. So we can calculate the change in energy, that is 470 kilojoule minus 240 kilojoule. So we will get 230 kilojoule. Now we can use the equation of power is rate of change of energy. So from this we can write down the change of energy is power times time, where power is voltage times current. So instead of power we can write V times I times T. In order to calculate time, we can make T as time as a subject. So we will get change in energy over voltage into current. So where change in energy is 230 kilojoule, which we have already calculated. So that will be 10 to the power 3 joule. Kilo we should convert it to kilojoule, we should convert it into joule. So we should multiply with 10 to the power 3 over voltage is the EMF of the battery, that is 12 times current flowing through the cell is 3.6, and the answer is 5320. Part 4. The filament wire of the lamp is connected in series with the adjacent copper connecting wire of the circuit as illustrated in figure 6.3. So the lamp's filament wire is connected to two copper wires in series. Some data for the filament wire and the adjacent copper connecting wires are given in the table. The cross-sectional area and number of density of free electrons. for both the filament wire and copper wire are given. Calculate the ratio of the average drift speed of free electrons in the filament wire over average drift speed of free electrons in the copper wire. So here, in order to find the ratio of average drift speed, we can use the equation which consists of drift speed, and that is current I is equal to number density times area of cross section times drift velocity times the charge of electron. But here we have two different wires. One is filament wire and the second one is copper wire. And in this equation, I is the current flowing through the wires, and as these wires are connected in series, both the copper and filament wires are in series, so that the current flowing through both the wires will be same. So we can use the same symbol to represent current. Same current is going to flow through these three different wires. But the area of cross section of copper and area of cross section of the filament wires are different. So we can use different symbols. For area of cross section of copper we can use AC, and for the area of cross section of the filament wire we can use AF. And number density of the free electrons for copper and filament wire are also different because it's completely depend upon the material. Number density is the number of free electrons available in that metal, which vary with the metal. So here the number density N will be different for copper, so we can represent NC and NF for filament lamp. And in the equation there is E, which is the charge of electron, which is also constant and same value in both filament wire and copper wire. So when we write the equation of drift velocity or average drift speed of the free electrons in filament wire will be equal to the current passing through the wire I. As it is common, we can simply write I over number density of filament wire times area of cross section of filament wire times charge of the electron. Again, charge of the electron is constant, so we can use the common symbol E. Similarly, we can find the equation for the drift velocity for copper wire. That will be is equal to, same current is flowing through copper, so we can use the same symbol I over the number density of copper, area of cross section of copper times E. Now we need to divide VF, drift speed of filament, over drift speed of copper. So this ratio will be I over NFAFE divided by I over NCACE. So we can cross multiply. So we will get I over NFAFE times NEACE over I, where I is common and E is constant, common. So we will get this is equal to number density of copper times area of cross section of copper over number density of filament wire times area of cross section of filament wire. These values are already provided in the table, so we can use these values. Number density of copper is 2.5 N, so 2.5 N times area of cross section of copper is 360 A. So here it will be 360 A over NF, that is number density of free electrons in filament lamp, which is N. So N times AF is A. So N times A. We can cancel this N and A. So the answer is 2.5 times 360. And the answer is 900. Since it is ratio, there is no unit. So here, for identifying or writing this equation, and substituting in this ratio, you can score 1 mark, and for the final answer, you will get the other mark. Question 7, Part A. The result of the alpha particle scattering experiment provide evidence for the structure of the atom. Result 1. The vast majority of alpha particles pass straight through the metal foil or are deviated by small angles. Result 2. A very small alpha particles is scattered through angle greater than 90 degrees. State what may be deduced from result 1. So result 1 says that the vast majority of the alpha particles pass straight through the metal foil without deviation. So we can see this is the result of Rutherford alpha particle scattering experiment, and when you are looking at the figure, we can clearly see that these positively charged alpha particles, when they are passing through the atoms of gold atoms present in the gold foil, most of the positively charged alpha particles are moving straight without deviating, and very less number of alpha particles are deviated with a small angle. Here you can see only one alpha particle is deviated greater than 90 degree and one alpha particle is deviated with a less angle. So comparing to the total number of alpha particle which moves straight without any deviation, there is a less number of alpha particles are deviating. The reason behind is, since the proton is positively charged and alpha particle is also positively charged, the nucleus which is positively charged, when the alpha particles meet or pass very next to the positively charged nucleus, they will repel. Then only these alpha particles will deviate. So from this we can understand that most of the alpha particles are not deviating because there is no nucleus, presence of nucleus, and the positively charged nucleus is only taking a very less space at the center of the atom. So that is the first conclusion we can make, that most of the atom is empty space, or the nucleus or the size of the nucleus is very small comparing to the atom. Then we can write most of the atom is empty space. Result 2, we should write the explanation for result 2. So now we should give reason why a very small minority of alpha particles scattered. Why these alpha particles scattered, or very less number of alpha particles are scattered at an angle. Because when they are moving towards the positively charged nucleus, as alpha particles and nucleus both are positive, they will repel away, and the size of the nucleus is very small. That is why the small minority of alpha particle is scattering. So first we can write about the charge, because both nucleus and alpha particle must be positive. So the first conclusion, the nucleus is charged. Next point we can write the majority of mass is in nucleus. Part B, a radioactive decay sequence contains 4 nuclei P, Q, R and S as shown. So initially we have an element with P. Its atomic number is 84 and mass number is 28, which undergoes a radioactive decay and a new product is formed. It's named Q with a atomic number 82 and mass number 214. So like this, there are 4 nuclei are present due to the decay process, as we can see. Nucleus S is an isotope of nucleus P. So that is very important information, that nucleus S is an isotope of nucleus P. So we should know about isotopes. If X and Y are 2 isotopes, they will have same atomic number, but mass number will be different. Such elements are known as isotope. So here in the question it's mentioned that P and S are isotopes. That means their mass number must be same. Atomic number must be same. The atomic number of P is 84. So that the atomic number of S also should be 84. So we can understand the atomic number of S is 84 as it is a isotope of P, which is mentioned in the question. Now we can look at what will be the mass number of this final product S. For that we need to check what kind of radioactive decay has undergone. That we can easily understand by checking this atomic number again. So basically there are three types of emissions or radioactive decay are there. The first one is alpha decay, then beta plus decay and beta minus decay. And we can look at the changes. What will happen to the atomic number or how atomic number will change during each emission. So after one alpha decay, there will be two loss in atomic number of the product. If it is a beta plus decay, there will be one loss in atomic number of the product. If it is beta minus decay, there will be 1 plus in atomic number, or the atomic number will increase by 1 in the product. So by checking these changes happen to the atomic number, we can identify whether it is an alpha decay or beta plus decay or beta minus decay. Now here we can check or compare these changes happen to the atomic number. So here we can understand from 84 to 82. So there is a change of minus 2, and we have already discussed if there is a change of minus 2, it must be a alpha decay, and alpha decay means alpha to 4. So the nuclei P has lost or emitted one alpha particle, that means 2, 4. Then the remaining will be 82 and 214, and that is correct. Then from 80 to 83. So here during this decay or this change we can understand the atomic number has increased by 1. So it will happen when there is a beta minus emission. So beta negative we can represent with -1 and 0. So when there is a beta negative emission, we will get the product R. Now again we can compare the atomic numbers of R and S. So the atomic number of R is 83 and atomic number of S is 84. So there is an increment of +1 from 83 to 84. So again it must be +1 change, that means it is a beta minus emission. So there is a beta minus emission, that means its atomic number will increase by 1, but the mass number will remain same for a beta minus emission. So the mass number of S will be same as the mass number of R, that is 214. Now part 1, determine the proton number and nucleon number of the nucleus S. So the proton number is nothing but the atomic number, and that is 84, which we have seen now. And nucleon number is the mass number, that is 214. Part 2, the quark composition of a nucleon in Q changes as Q decays to form R. Describe this change to the quark composition of the nucleon. So here we should check when Q decays to form R, we need to describe the change to the quark composition of the nucleon. So we can see when Q changes to R here, there is a beta negative emission, which we have already seen. So I am writing that equation here again. So we can write, initially we have a nucleus of Q, that is 82 with a mass number of 214, but we have seen which will produce another nucleus of R with atomic number 83 and mass number 214, and it is due to the emission of beta negative particles. Now we need to think about how a positively charged nucleus here is producing a negatively charged beta particle, because we know that there is no negatively charged particles inside a nucleus. Then still how it is producing a beta negative particle or a particle with negatively charge. So here we need to understand the process. One of the neutron from the nucleus of Q, so neutron has zero charge as we know that, which will split into a positively charged proton with one positive charge and a negatively charged beta negative particle. So during the emission of a beta negative particle, what really happening to the nucleus is very important. One of the neutron from the nucleus split and form one proton and one negatively charged particle, that is beta negative particle, and this positively charged particle stays inside the nucleus, but negatively charged particles, they will emit out. So here we can see a neutron inside the nucleus changes to a proton. So in terms of its core composition, the core composition of a neutron is 1U and 2D, and it changes to proton. So the core composition of proton is 2U's and 1D. So we can understand that the core composition from UDD to UUD is changing because of this beta negative emission. We can write UDD to UUD. Thank you for watching the video. If you find this video useful, please like this video and subscribe my channel. Thank you.